If I ask you what fire is, can you answer? And no, you can't just say it's something hot and shiny. Today, we're going to uncover what really happens inside these mysterious flames. And believe me, there's more science here than in a Hogwarts potion. And if you think fire is just fire, wait until you see how it behaves in space. Yes, that's right. Fire doesn't always act the way you think it does. At school, they probably taught you that fire can be explained with a simple formula. Fuel plus oxygen plus heat equals fire. Okay, that might be useful in chemistry class, but this equation explains fire about as well as a cake recipe explains the taste of a delicious chocolate chip cookie. Fire isn't a thing. It's not a solid, not a liquid, and not even a gas. Fire is actually a process, a chemical reaction happening right before your eyes. And it's wild. To really understand fire, let's take something simple, a candle flame. You've probably seen one hundreds of times, but have you ever really looked at it? Take a close look at a candle flame. It's not just one color, is it? If you observe carefully, you'll notice at least 3 different colors: blue, yellow, and orange. But why? At the base, right near the wick, the flame glows blue. That's because this part is super hot and the electrons and the molecules are jumping around like popcorn in a hot pan. In the middle, it turns yellowish because things start to cool down a little. At the top, the flame is orange because tiny bits of carbon, little leftover pieces of the candle, start glowing. This is exactly what happens when you see embers burning in a campfire or charcoal on a grill. Now look carefully at the very center of the flame. See that dark part near the wick? That part isn't actually burning. That's because fire needs fuel. But before it can burn, that fuel has to be turned into a gas. In this case, the wax in the candle melts, evaporates, and turns into gas before it actually ignites. This is called pyrolysis, which sounds like a fancy spell from a fantasy movie, but is actually the key to how all flames work. Here's a cool experiment you can try. Take a cold metal spoon and hold it near the flame. You'll see little water droplets appear on the metal. Yes, fire creates water in the form of water vapor. Now hold the spoon closer to the yellow part of the flame. It will turn black with soot. That's the unburned carbon that didn't have time to fully react. This is the same stuff that builds up inside chimneys, and in extreme cases, it can even cause chimney fires. Fire doesn't just happen on its own. It needs a little push to get started. When I strike a match, it generates enough heat to begin a process called, get ready for the villain's name, pyrosis. Sounds scary, right? Well, it kind of is. This means that the fuel is breaking down into smaller molecules, turning into gas, and starting to react with oxygen. And then a wild chain reaction begins. Molecules collide like cars in a chaotic traffic jam. Electrons get excited, then drop back down, releasing heat and light. The heat keeps the reaction going, feeding itself like a hungry fire monster. It's basically a chemical traffic accident happening at high speed. And once it starts, it won't stop unless we remove one of the 3 key ingredients: fuel, oxygen, or heat. Now, here comes the crazy part. What happens if I light a candle in space? Well, it doesn't look like a normal flame at all. On Earth, gravity pulls cool air down while hot air rises. That's what gives flames their familiar teardrop shape. But in zero gravity, this doesn't happen. Instead, the fire just sits there like a little glowing ball. No flickering, no rising smoke. Just a perfect sphere of flame. In space, fire behaves much more unpredictably. It spreads differently, burns differently, and can even be harder to put out. That's why astronauts on the International Space Station have to be super careful with anything that might ignite. So, what actually keeps a fire burning? It's simple. Fire needs these things. 1. Fuel. Something that burns. It could be wood, gasoline, or even your toast if you leave it in too long. 2. Oxygen. The fire needs to breathe, just like we do. Without oxygen, it dies. 3. Heat. Fire must be hot enough to keep breaking apart molecules and making more fire. If you take away any of these 3 things, the fire goes out. That's why water works to put out most fires. It cools everything down, so the heat isn't enough to keep the reaction going. But wait, never throw water on a grease fire in the kitchen. If you do, the water turns into steam instantly, expanding and throwing flaming oil everywhere. Yes, you basically create a mini explosion in your kitchen. Instead, you should cover the fire with a lid to smother it. Fun fact: firefighters sometimes use foam or special gas extinguishers instead of water because they cut off the oxygen supply instead of just cooling things down. Fire, our first technology. Since the time of cavemen, fire has been our first smartphone. It kept us warm, cooked our food, and protected us from predators. Without fire, civilization as we know it wouldn't exist. But fire can also get out of control really fast. That's why we have fire departments, smoke alarms, and fire safety rules. So, the next time you look at a flame, remember, inside that glow there's a real chemical show happening, a dance of energy atoms and physics. And as the saying goes, with great power comes great responsibility. Or in this case, never leave a candle burning alone. Did you like this video? Then hit the like button, subscribe to the channel, and turn on notifications. And remember, stay curious, but don't set anything on fire, okay? See you soon.